Today we're going to take a look at leveraging the render network to create a dataset to train some modular Gaussian splats. I want to take a quick moment to show how awesome the new Octane 2025 decal system is. With a decal container, you have full placement control on your object in the viewport, and you can swap out decal designs quickly and easily through the node graph. Simply hook up the image, and if it's a transparent PNG it's even better, because you can duplicate the image node and then set the type to alpha and plug directly into the opacity. It's such a cool feature, and it was heavily used when building the 3D assets used to train the splats. But let's get back to the splat building. The initial goal is to develop a dataset to train the Gaussian splat. What that really means is we need a lot of surface coverage of the model or the scene. Currently there is no direct one-to-one 3D to splat method, so we have to capture the details of the object, render them as frames, and then use those when building out the Gaussian splat. Here I'm using an orbital camera traveling around my object, and then a bit tighter panning towards the end of the sequence. The final result is I get great coverage all the way around multiple times, and I get some tight angles so I can see some details. We want to develop a system where we could potentially replace new materials or adjust lighting and retain the asset fidelity. So we're going to use the render network to send two different datasets of the same asset and train the splat with both datasets. What I mean by datasets are two 440 frame sequences of images, both rendered on the render network quickly and efficiently. I've already uploaded and rendered both sequences, and we can see how both sets vary with materials, lighting, and the floor is also different. Splats process image data differently to react to metallic and translucent data. So we'll see how close in proximity these two variations of the same asset end up being, but right now I think we have a great source to begin. Next, we just need all of our outputs. So we use the Render Network Download Manager to download everything back to our PC. It's always good to review your outputs and just check for consistency before diving into the alignment phase. This next step is optional, but it will help with consistency and overall quality. Metashape allows us to wrangle point cloud and camera data all in one, with extremely good point cloud and camera alignment, as well as filtering tools. You may hear the term COLMAP, which is exactly this process. And it's a consistency method we're going to use to leverage and train the second dataset without having to realign things. Once we're in Agisoft Metashape, we can drag the whole folder of images directly into the workspace to create a chunk of images. The images will then all load and they'll be ready for alignment. If we then go to Workflow and select Align Photos, this is where we'll set our parameters for camera alignment. I always use high accuracy, and since we know our render outputs are a sequence along a path, we can select sequential. And this will allow the software to use bias towards frames before and after each other to enhance the alignment. Key points and tie points are points both found in each image and points matched to other images. You can set limits to speed up the alignment process, or you can leave these as 0, and that allows the software to find and match unlimited points to each image. If you have a good GPU, this is fine. Otherwise, I'd suggest limiting these values. If everything looks good, you can click the OK, and the alignment process will begin, finding and aligning images to other images. And you can watch both the console or toggle the details to see the processes running. On a small dataset, this could be minutes. On a large dataset, it could be hours, so you have to be patient. Once the alignment is done, you'll see the full point cloud generated in 3D space. You can look to see each point assigned to each image as well, which is a neat feature. This is actually the same step you go through with photogrammetry as well. There are a lot of relative aspects of Gaussian splat training that align with those of photogrammetry, so it's not completely different in those regards, but the final result will be much different. From here we can start to fine-tune and clean up the points just a bit. Agisoft Metashape has industry-leading filtering tools to help clean up point clouds, and I use those along with some manual selections to tidy things up. If we click on the camera icon, we'll get our 3D cameras generated from the alignment process, and we'll notice the cameras look incredibly close and near exact to the Cinema 4D camera orbiting path. Once we're ready to save things, we can go to File, Export Cameras, and this will prompt us to save a package of COLMAP data. We'll need that to apply later during the splat training. And now we're ready to train our splat data. And to do that, we're going to open up Jawset PostShot. PostShot is an end-to-end software for radiance fields, and is designed and optimized for production. There are user guides and tutorials online, as well as an active Discord channel and active software development, with some industry-leading splat throughput for videos and images. To get started, we could have jumped straight to PostShot from the render network, and I'll show you an example of that shortly. But for now, we're going to take the package of exported COLMAP data from Agisoft, and we're going to drag that into the PostShot import window. From there, we'll get an import dialog with training settings. It should have the image selection set to all, with 441 images for this dataset, frames 0 to 440. Camera pose is set to import. Since we already aligned cameras in Agisoft, this is a huge benefit that allows us to mitigate retraining cameras. Radiance field profile with Splat 3 being newer and really strong radiance field type, we'll keep that. Max splat count sets the limit of splat training for your model. I usually keep this at the default. Stop training after X amount of steps can be used as a default, or you can push steps to a high amount and always simply pause your splat training at any time along the way. I always prefer a higher step training, and I feel I get the best results around 60 to 70 minimum steps. You can always circle back and retrain with different settings, but once you feel good, you can click import, and the splat training will begin. We can see at the bottom right that training radiance field has started. And we see several 3D camera wireframes in the window. This is what we want, and if we didn't upload the COLMAP data, it would indicate that it's in a similar alignment phase that Agisoft had already done. Now we can see the steps training, and we can scroll out and we can see progressive splat training away. At any time we can click pause training, and then we'll be able to hover around much more smoothly, and we'll be able to see the splat at an early state. Initially things will look extremely blobby and low res, but don't worry, the details will finesse and start to show with more steps. Usually by 13 to 15 steps, you have decent fidelity. Your first thought may be to grab some selection tools and delete some of the black areas that you don't want. But if you do this and then start the training back up, the splats will start to rebuild themselves. You typically want to hold off and clean up at the end of the training. The training itself is a blend between the camera data, the images, and the point cloud data. So what you see early on may not be the final result, so be patient and let the process happen. The entire training could take hours, but for the sake of the video I've already processed, so let's take a look. I have the background removed from the scene and isolated with the brush tool to clean things up briefly. The internal PostShot tools are great for quick edits and some minimal cleanup. Splats in general don't currently have a wide list of functional tools out there to use for cleanup, so we're just going to use different tools shortly. But for now, while we have the splat in PostShot, we'll use the brush and start cleaning things up and isolating further. This is where you want to decide what part of the splat you want to retain as a modular asset. In this case we want the floor and the guitar, but we're going to isolate the guitar for now. Sometimes splats are difficult to see visually, so selecting the regions you want to keep and inverting the selection to delete floating and hard to see splats is the best solution. Once everything looks good, we'll export out the .ply format to use for later. Now let's take a look at the trained version in PostShot directly from Render Network with no Agisoft alignment. The first thing you'll notice are splats are everywhere. It's chaos, and this can be a difficult thing to manage at times. In this instance, just to find the asset we want, we're going to have to clean up a lot of information and start hacking away and deleting a lot of splats. It is interesting to have all of these floating residual data surrounding the object, and that could be a stylistic thing you're after, but for me in particular, I just want the crisp, clean version. You'll also notice some of the information looks foggy or misaligned. That's because the alignment in Agisoft is really good, and that's why I use it often to align my cameras first. So let's hop over to the experimental splat, and what I mean by that is using the COLMAP data from the first aligned sequence, we just replaced the image dataset and retrained the splat in PostShot, and here are the results. It's honestly pretty successful, and I was surprised. But rather than clean this one up in PostShot like the other, let's dive into SuperSplat Web Editor and take everything from there. SuperSplat is a user-friendly and free online splat editor that you can import your splats, edit them, realign them in 3D space, and export and even compress them. I already have all the splats loaded in line, but let's take a look at some of the functionality. If we hover in, we can look at some of the tools. The lasso tool is a great tool to go in and make custom selections. To delete an area, just hit the delete button, but sometimes you make mistakes, so Ctrl-Z is available. With both datasets for the splats trained and uploaded, this is where we can align and prep them for later. We can even import other splats and build full splat asset packages that we know will align well on import for other platforms. In this case, I have a guitar separated and aligned, I have the floor separated and aligned, and I have a splat I made a while back using real-time footage from Embergen to capture some swirling fireballs as a baked volumetric splat. When working with certain splats, you can use low or high spherical harmonics, and that'll help compress the overall size if it's set to 0. But if your splat has a lot of translucency that you want to retain visually so it doesn't appear flat, then you may want a higher spherical harmonic setting to 2 or 3 before export. As you can see, these splats are running in real time on the web. This offers a substantial new method and medium for really unique and impressive 3D assets that don't rely on heavy geometry or shaders, and you can get near one-to-one results from many million poly assets with dozens of large AK textures, all inside several megabytes a container of a splat. Let's take a look at this nice plugin for Nuke, Resolve, and After Effects from Irrealix to visualize Gaussian splats in real time that you can quickly use with 3D cameras and even some cool effects. Splats give you access to 3D data on demand, and it's really great to see the evolution. With splats isolated and aligned properly, you can use them really swiftly inside projects and swap them seamlessly. So let's jump into Octane 2026.1 Alpha 3 and see how assembly with splats can be just as effective as other full 3D assets. If you haven't seen the Part 1 Gaussian Splats intro for Octane, I recommend watching it to understand a bit more of the splat settings for the Gaussian Splat node. Here I already have some pre-built scenes utilizing the splats we just created earlier alongside some 3D scattered grass in the daylight. Since the splat nodes don't have transforms, we have to use a placement node so we can transform them in 3D space. If we hop into a different camera view, and then we enable the translation icon, we can move the splat around. Since we already have both datasets trained, cleaned up, and aligned, we can use a geometry switch node and effortlessly toggle between the two splats. We can add or remove inputs, and this makes it really easy for us to have different iterations of the same asset, especially with splats. And this is great, because now our splat nodes can be independent and have all of their own properties, but at the end of the day, if we want to swap between them, all we have to do is go to the geometry switch node and change the input. The speed of these splats rendering is nearly 5 times faster than the speed of the 3D guitar with the decals and all of the geometry. To me, that's amazing. If we enable shadow visibility to get self-shadows, we can practically fully relight and integrate these with the 3D assets in the scene. And again, with this setup, we have full modular control. So if we want to adjust this particular splat to have different shadows, different effects, and look a little bit differently, we can. And then we don't affect the other splats. So if we use the geometry switch node again and hop back over to the other splat, then we have full control to change that splat as we need as well. And as you can see, this splat with the self shadows may not look too good, and it might look better just having the baked in look. And it's nice to have that flexibility and control. And this flexibility goes a long way. We can start to add a few more placement nodes for instancing, and we can begin mixing iterations and adjusting those properties based on each iteration. And ultimately, this creates a very relative environment that we already have with modular 3D assets, and we can use Gaussian splats in the exact same fashion. So let's jump into another scene where we can use the guitars and the floors independently. Again, we have geometry switch nodes now controlling each one of the assets, but we also only have one light in the scene, and that's actually lighting the entire scene. All of these assets are already pre-baked with their lighting, but we're using self-shadowing on each one of the splats themselves and on the floors to cast new shadows. We're also using the floors in an interesting way here too. We're using them as a plate almost. With the placement nodes, we can instance them to the left and the right and create a grid of the flooring. The biggest issue and constraint here is the baked-in lighting with all the shadows. But just like we did with the guitar, we can use the geometry switch node and use both floorings interchangeably. We could easily pull back in the 3D floor, and we could use that because that doesn't have lighting baked in. But depending on how we use this floor in this grid, I think it could still work. The idea would be that the lighting itself could be mitigated by a single light, or something that could cut off the light. In this case, we could use an analytical light that has a fall off and a spread that we can use like a spotlight. And that would give us this effect, and it actually kind of works. It's always going to be a balance of the intensity of the radiance field itself and the lights in the scene, but I think it's pretty fun to play around with. We can even use lights stylistically and get that edge rim look, which is really cool. What would really make this scene a little bit more magical is some volumetrics. So let's go ahead and add in this fireball. This is another area I think splats can be super handy. Adding real-time volumetrics and VFX to images is going to be amazing. The cheat with this sort of asset is that we can turn the visibility down super low, but then crank the intensity on the splat itself. Or, we can enable the lighting mode, and we can clamp the splat with the lighting itself, which is really interesting. I hope you guys found this interesting and you're excited as much as I am about the new opportunities Splats will offer. If you have any questions, feel free to reach out. And if you want to show off some of your own Splats, please do and share back your results. Until next time.